Hello dear students. So in this video we are going to discuss the topic of projectile motion. Okay. Now this topic is with reference to the chapter motion in plane. Motion in plane. Okay. Motion in plane. So when we say plane, so we need two dimensions to define the position. Okay. Plane means suppose this board is a plane. Okay, so suppose this is a plane. Okay, now if suppose an object is at this particular location, so I need to define this position. I need distance traveled in this direction. Suppose this is x-axis and this is y-axis. So this position can be defined. Suppose this is x1 and this is y1. So this coordinate will be x1 comma y1. So to define this position, I need two coordinates. So that is motion in plane. It is also called motion in two dimension. That is, two dimensions are required to define a particular physical quantity. Okay. So what is this? How is it related to projectile motion? Okay. Now see, one type of this projectile motion we have studied in the chapter motion in straight line. Okay. Wherein suppose this is the ground level. An object, it is projected in the upward direction with velocity, some velocity u. U is the velocity. Okay. Now, see, when this object moves in the upward direction, it is acted upon by a gravitational force. What is the direction of the gravitational force? It acts in the downward direction. So, if the force is acting in the downward direction, acceleration will also be in the downward direction. So, in this case, velocity is in the upward direction and acceleration it is in the downward direction. Acceleration which is in the downward direction. So this object will move like this, it will go upward and then it will come down. Okay. Now in this case, while going upward, the angle between the direction of velocity, see velocity is in the upward direction, acceleration is in the downward direction. Okay. See, while going upward, velocity is in the upward direction, acceleration is in the downward direction. So what is the angle between velocity vector and acceleration? It is 180 degree. 180 degree, because see, while going upward, velocity is in the upward direction, acceleration is in the downward direction. So angle between velocity and acceleration, it is 180 degree because they are in opposite direction. Now while coming downward, velocity it is in the downward direction, acceleration it will always be in the downward direction. Acceleration, it is always acting towards the earth. Acceleration is always towards the earth. So both the velocities and acceleration, they are in this downward direction when it is coming downward. So in this case, both the vectors are in the same direction. So angle between them will be how much? 0 degree. So theta is equal to 0 degree. Okay. So as you can see, similarly, suppose another case, if an object is dropped. So in this case, obviously, this is the similar case. Velocity and acceleration, they will be same direction. Velocity is in the downward direction. Acceleration will also be in the downward direction. So angle between them will be 0 degree and it will come in this direction. Correct? So that means if the angle between velocity and acceleration is 180 degree or it is 0 degree, the object moves in a straight line. The object moves in a straight line. Okay. So this is what we have studied in the topic motion under gravity. Okay. So these things we have studied. But why I am explaining this once again, to analyze that what difference we are going to see here. So previously we have seen cases where velocity and acceleration, either they were in the same direction, that is when the angle between them is 0 degree, or they were in the opposite direction, that is when the angle between them is 180 degree. Okay. So now what happens in this projectile motion or in this topic chapter of motion in plane? Now suppose this is the ground level. This is the ground level. Okay. And object is projected like this. So this is the direction of velocity. Object is projected at some angle theta. Okay. And what is the direction of acceleration? It is always in the downward direction. So this is the direction of acceleration. Acceleration is in the downward direction. So what happens? See, here velocity and acceleration. Here the angle between them Angle between velocity, see this theta is the angle with the horizontal, okay. This theta has nothing to do with the angle, nothing to do with the angle between velocity and acceleration that we have defined before, okay. So this theta is something else. I will define it later. But now I am saying that this theta is the angle made with the horizontal. This velocity, this is the surface of Earth. This is the direction of acceleration. Acceleration will act in the downward direction. Earth pulls all objects in the downward direction. Here, the angle between velocity and acceleration, it is not 0 degree. It is not 0 degree. Neither it is 180 degree. Okay. Neither it is 180 degree. Neither it is 0 degree. Neither it is 180 degree. Okay. So if I throw this chalk like this, so see it goes like this. It travels in this path. Correct? So this object, if it is projected like this, it will go like this and it will hit the ground again at this particular location. Suppose if you throw a stone, or if you throw a shot put, or if you throw a javelin, this is how it travels. Don't say we throw shot put in the upward direction or javelin in the upward direction. It will be very risky. So you'll be throwing because while throwing the shot put or the javelin, your goal is that shot put or the javelin should travel as far as possible so that you are able to win a medal. Okay. So now in this topic, we are also going to identify the condition for which this shot put or the javelin will travel maximum distance. Those conditions also we will find out. Okay. So there is a science behind that. In fact, there is a physics behind that. Okay. Now see, so this kind of motion we are going to study, wherein the velocity and acceleration, angle between them is neither 0 degree nor it is 180 degree. Okay. And the object will move in a parabolic path. The object will move in a parabolic path. We prove that the path is parabolic. Okay. And or presently we'll say that okay, it is traveling in a curved path for timing. Okay. Till we prove that the curve is in fact parabolic. Okay. So so this is the kind of motion we are going to study, and that kind of motion is called projectile motion. Okay. But why this word projectile? Why this word projectile? Because this object is projected in space, that is on the surface of Earth, and once the object is projected, it moves purely under the influence of gravity. Okay. It moves purely under the influence of gravity. Okay, this is one condition for an object to be called as projectile and the motion to be called as projectile motion. Means projectile motion is the kind of motion where object moves purely under the influence of gravity. Means after projection, you have to project it. Okay, without projecting an object simply placed on Earth, it is not going to move on its own. Okay, you have to project it, but after projecting, it is going to move under the influence of gravity. Okay. The other condition is the object should move close to the surface of Earth. Okay. Object moves close to surface of Earth. Why I am saying that it should move close to surface of Earth? Because if it moves outside, means in the outer region, the influence of gravity may decrease. Okay, because already we have put the condition that it should move under the influence of gravity. So that is possible only when the object moves close to surface of Earth. Okay, and there is another condition that we are going to put here is that we are going to neglect the influence of air. We are going to neglect air resistance. We are not going to consider air resistance. Okay, air resistance is not considered. Okay, so when we are saying that the object is undergoing projectile motion, that means it is satisfying these three conditions. Okay, and under the influence of these three conditions, it will move like this, provided this velocity and acceleration, they don't make an angle of 0 degree or 180 degree. Okay, now another important thing is, like see, when it is moving under the influence of gravity, so that means, see, at each and every point, at each location, the acceleration due to gravity, it will act in the downward direction. So that means throughout the course of motion, acceleration is constant. Okay, so that means here the object is moving under uniform acceleration. Uniform acceleration. The object is moving under the influence of uniform acceleration. Now, why this condition is important? This condition is important because we have derived the three equations of motion. Okay, we have derived that v is equal to u plus at, s equal to ut plus half at square, v square minus u square is equal to twice as. Now these are called equations of motion. Equations of motion. Equations of motion. And these equations are valid only under the condition when acceleration is constant. This a must be a constant. If acceleration is not constant, you cannot use this equation. If your object is moving such that its acceleration is not constant, then you cannot study its motion using these equations. Okay, so equations of motion valid for constant acceleration. Constant acceleration. Okay, so now here uniform acceleration means constant acceleration. So that means for projectile motion, to study projectile motion, we can use equations of motion. Okay, so to study projectile motion, to study this projectile motion, we can use equations of motion. Okay, so using this equation we are going to derive various conditions related to projectile motion. Okay, so this is the fundamental background behind the topic of projectile motion. Okay, projection, angle of projection. Okay, so now the object takes this path and finally reaches this point. Okay, now this is the origin, so this coordinate is 0, 0. Okay, suppose this is O, this is A. Okay, now O to A, this distance is suppose R. This distance is R. So we will call this R as horizontal range. Horizontal range. That is the distance travelled along the horizontal direction. Okay. So coordinate of A will be obviously R, 0. Coordinate of A will be R, 0. Y coordinate will be 0. Correct? So at any point along this x-axis, y coordinate will be 0. So this distance is R. So this will be R, 0. Okay. This is the maximum height. So we will represent it as h. H is the maximum height. Okay. Now this is u. So I can resolve this u along x-axis as ux and along y-axis as uy. Okay. Now, what is the direction of acceleration? Acceleration is acting in the vertical direction. Okay. So that is ay. Vertical direction is y-axis. So acceleration along y-axis, it is equal to minus g. Why I am writing minus g? Because velocity is in the upward direction. This is in the downward direction. Okay, so we are taking upward direction as positive, downward direction as negative. That is one way of understanding this. Another way is, this is, see, when the object moves in the upward direction, it will undergo retardation. So this represents retardation. Okay, so ay is equal to minus g. Ay is minus g because we are taking acceleration along the vertical direction. Because acceleration, it is not the point of taking it. Because acceleration will always act in the vertical direction because Earth is pulling all objects in the downward direction. So force is in the downward direction, acceleration is in the downward direction. So ay is equal to minus g. Okay. When the projectile moves from this point to this point, acceleration is acting in the downward, in this direction, vertical direction. There is no acceleration along horizontal direction. There is no one to pull this projectile along horizontal direction. So acceleration along x-axis, it is 0. So this is a very important concept, acceleration along x-axis. For projectile motion, acceleration along x-axis, it is 0. Acceleration along y-axis, it is minus g. Okay, so see this velocity, I have broken it into ux and uy. Ux is the velocity along x-axis, uy is the velocity along y-axis. Now, if this is u, this is theta, what will be ux? This component will be u cos theta. So ux will be equal to u cos theta, uy is equal to u sin theta. Uy is equal to u sin theta. Okay. So see, this is the velocity. U cos theta is the velocity in this direction, and u sin theta is the velocity in the upward direction. So u cos theta will move the projectile in this direction, and u sin theta will move the projectile in the upward direction. But in the upward direction, this retardation will take place. So that means, see, when velocity and acceleration, they are in opposite direction, then the object undergoes retardation. When velocity and acceleration, see, if I throw this chalk in the upward direction, what happens? I'm throwing this chalk in the upward direction, so velocity is in the upward direction. Acceleration, it is in the downward direction. That is why when I throw this chalk in the upward direction, velocity decreases. So suppose I'm throwing this chalk in the upward direction with the velocity of 5 meters per second. So the velocity will be 5 meters per second, 4, 3, 2, 1, 0. When it becomes 0, it starts coming downward. So that means, see, when it is going upward, the velocity is decreasing. Why the velocity is decreasing? Because acceleration is in the downward direction, velocity is in the upward direction. So when velocity and acceleration, they are in opposite direction, the velocity decreases, gradually decreases till it becomes 0, and then it changes the direction. So this thing also happens here. So this velocity uy, that is u sin theta, this velocity will keep on decreasing. Okay, but this velocity ux, it will remain constant because acceleration along x-axis is 0. So this velocity, it will remain constant, and this will be decreasing. This will be decreasing. It will be decreasing only till this point. At this point, the velocity will become 0. So what happens? See, this is ux. So this ux, it remains everywhere ux. Ux. Here also it is ux. So at any point, the horizontal velocity is not going to change, but this vertical velocity is going to decrease. So here it is, suppose vy, ui. Here it is ui. So here the length of the vector I am going to decrease it. Why? Because magnitude is going to decrease. At highest point, velocity vy, it is going to be 0 at highest point. At this point, the directional velocity will change. Okay. And here again, it will acquire the same magnitude, but in the opposite direction. Okay. So see, so here the velocity is like this. Okay, here it is decreasing the magnitude. Here the velocity becomes 0. After this, the velocity reverses the direction. The vertical component, I am talking about the vertical component. And then again, here the magnitude has increased. Here it is further increased. While coming downward, the velocity will increase, this vertical component. While going upward, the velocity component will decrease. At highest point, it will be 0. But this horizontal component of velocity, it is not going to change because along horizontal direction, acceleration is 0. So since acceleration is 0, velocity will remain constant. Okay. So this is how the object is moving. Okay. Now another important thing is, see, this velocity u cos theta, it is the velocity in this direction. So this velocity is taking the projectile in this direction, because if you have velocity in a particular direction, there will be a displacement. So this u cos theta is taking the projectile in this direction. U sin theta, it is taking it upward, and then it is also taking it downward. So the projectile goes in the upward direction, but while going upward, this u cos theta is pulling it out in the forward direction. So it has moved from this point to this point. Then from this point to this point, this vertical component of velocity reverses the direction. So again the velocity is going to increase when coming downward. But again, this u cos theta is acting continuously. So it is taking this projectile from this point to this point. So this projectile is moving from this point to this point under the influence of these two velocities. Both the velocities are responsible. Okay, acha. This velocity keeps on changing, this remains constant. Okay, acha. So now, if we write the equation of motion, S is equal to ut plus half at square. This is the equation of motion. Okay. Now, here the motion is taking place in two dimensions. It is taking place in two dimensions. So, for motion along x-axis, here the object is moving along x-axis, it is also moving along y-axis. So for motion along x-axis, I will break this equation as x, this is displacement along x-axis, this is initial velocity, I will take initial velocity along x-axis, t time plus half ax, this is acceleration, ax means acceleration along x-axis, t square. T is same, time will be same for x-axis and y-axis. Okay, time is not different. So time, I am writing it as t. Now similarly, for motion along y-axis, this is x displacement along x-axis. So similarly, we will have y displacement along y-axis. Ux, this is the velocity along initial velocity along x-axis. So we will have initial velocity along y-axis t plus half ax. This is acceleration along x-axis. So here we have acceleration along y-axis t square. Okay. Now let us substitute the values. So this is x is equal to, what is ux? Ux is u cos theta, initial velocity along x-axis. So u cos theta into t. The second term vanishes. Why? Because ax equal to 0. So this entire term becomes 0. So I have x equal to u cos theta into t. Okay. Similarly, here we have y is equal to, what is uy? Uy is u sin theta. So this is u sin theta into t. What is ay? Ay is minus g. So this is minus half gt square. Okay, minus half gt square. So this is another equation. Okay, always box the important equations so that they are clearly visible to you when you are revising it in a short time. Okay. Now from this I can write t is equal to x by u cos theta. T is equal to x by u cos theta. So if I substitute this t in this equation, okay, this t is substituted over here. So what do I get? Let me rub this part. So if you make the substitution, you will get y is equal to u sin theta. T is x by u cos theta. So x by u cos theta minus g by 2 t square. So that is x square by u square cos square theta. Okay. So this u and u gets cancelled. So what do I get? Y is equal to sin theta by cos theta is tan theta. So x tan theta minus gx square divided by 2u square cos square theta. X tan theta minus gx square divided by 2u square cos square theta. Okay, I hope you are also getting it, and I believe you are also writing along with me. Okay, so this is an equation involving x and y. Okay, involving x and y. Okay, so here, see, what is theta? Theta is this angle. What is u? U is the velocity of projection. Okay, what is g? That is acceleration due to gravity. So if these values are substituted, so if you substitute all these values, okay, then now you will have an equation of this form, suppose general form, y is equal to ax plus bx square. Okay, suppose this a represents here this tan theta, and b represents all these terms minus g by 2 u square cos square theta. Okay, now this, what is this? Here a and b are some constant, okay, these values. Now if you substitute these values for, say, x equal to 0, you write the value of y, x equal to 1, you write the value of y, and if you plot all those values, okay, x and y, you take the values, okay, and then if you plot, you will get this path, okay. What is this path actually? This is the path followed by the projectile under the influence of gravity, isn't it? The projectile is taking this path. This path is called trajectory. Okay, this is the path followed by the projectile under the influence of gravity. Okay, path followed by projectile under gravity. So this path is called trajectory, and if you are making the substitution for x and y, you are getting the same path. So that means this equation represents the equation of trajectory. Okay, so this is equation of trajectory. Okay, this is first point of observation. Okay, second point of observation is this equation. This is standard equation for parabola. Okay, so that means this trajectory, this shape of the trajectory is parabolic. So trajectory is parabolic. Okay, trajectory is parabolic. So in exam, if you are asked, prove that the trajectory of the projectile is parabolic, then you have to make this deduction and finally obtain this equation and deduce that this is the equation of parabola, so therefore the equation of trajectory is parabolic. Okay, so this is first important result. Okay, now we have the equation y is equal to x tan theta minus gx square divided by 2u square cos square theta. Okay, now I can write this equation as, if I take x common, I can write this like this. Okay, now see, this equation represents this path. Okay, now for this point, the coordinate is x equal to 0, y equal to 0. This is for origin. Okay, for this a, this is for a, x is equal to r, y is equal to 0. X equal to r, y equal to 0. So that means for both origin and point A, the y coordinate is 0. Okay, y coordinate is 0. That means if we make this y equal to 0, you get two solutions. One solution is x equal to 0. So one solution is x equal to 0, means this is x equal to 0. Okay, means y equal to 0 means x equal to 0. Y equal to 0 means either x equal to this quantity is 0 or this quantity is 0. Correct? This quantity is 0 means x equal to 0. That is this location. And if this quantity is 0, we will get x equal to r, isn't it? So if we make this quantity equal to 0, this x will becomes r. What is r? R is the horizontal range. Correct? So let us make this quantity 0. So tan theta minus gx. Now x is equal to r. So I am replacing this x with r. So gr divided by 2u square cos square theta is equal to 0. This is for condition y equal to 0. Okay. For y equal to 0, see y equal to product of these two terms. So for y equal to 0, either x equal to 0, so that is this condition, or this term equal to 0. But if this term is equal to 0, that represents x equal to r. So I have made x equal to r. Okay, so if I take this term on that side, so tan theta is equal to gr divided by 2u square cos per theta. Okay, so r equal to 2u square cos square theta tan theta by g. Okay, what is tan theta? Tan theta is sin theta by cos theta. So tan theta can be replaced by sin theta by cos theta. Okay, so if you simplify this, cos theta gets cancelled. Okay, so this term becomes r equal to 2u square sin theta cos theta by g. Okay, I can write it like this, or I can write it like r equal to u square sin 2 theta by g. Okay, so this is the expression for range, this distance. See this expression 2 sin theta cos theta, 2 sin theta cos theta is sin 2 theta. Okay, sin 2 theta is equal to 2 sin theta cos theta. Okay, so I have made this substitution over here. So this is the formula for range, r equal to u square sin 2 theta by g. So what is the range? Range is the maximum distance traveled by the projectile in horizontal direction. Okay, horizontal range definition, you can write it as maximum displacement or total displacement. You can write total displacement because that is the total displacement along horizontal direction. So total displacement of projectile along horizontal direction. Okay, so this is horizontal range. So when the projectile moves from this point to this point, this horizontal displacement, it is horizontal range, and the expression is u square sin 2 theta by g. Okay, so now we have found the distance from this O to A, that is the horizontal range, and we have found that this range it is equal to u square sin 2 theta by g. Okay, so that means obviously this range changes with this theta. Suppose u and g is fixed. Okay, so by varying theta you can change the value of the range. Okay, now let us see under what condition this range becomes maximum. So for maximum range, that is r is equal to r max. If you want this quantity to be maximum, keeping u and g fixed, g is not going to change, g is fixed, u is also suppose fixed. That is your maximum ability. Means suppose you can throw the shot put with a particular velocity. You can't throw beyond that. So by varying the angle, you can change the range. You can increase the range. Okay. So r equal to r max. For range to be maximum, this u and g is fixed. So this quantity sin 2 theta should be maximum. Okay. So for r equal to r max, sin 2 theta should be maximum. So what is the maximum value of sin, or that matter cos? Maximum value of sin or cos is plus 1. So sin 2 theta maximum value is plus 1. Okay, sin 2 theta is plus 1 means sin 2 theta is equal to sin 90 degree. So that means 2 theta is equal to 90 degree or theta is equal to 45 degree. So that means if you throw a shot put or the javelin at 45 degree, then the range will be maximum. This range will be maximum. And what will be the maximum value of the range? So sin 2 theta, when the sin 2 theta becomes 1, range becomes maximum. So r max, it will be equal to how much? It will be equal to u square by g for theta is equal to 45 degree. So this is the expression for maximum horizontal range. Okay, another important thing is, see, this is theta So this will be, suppose this angle, this is same velocity u, but suppose this angle is 90 degree minus theta. Okay, it is like, suppose this theta is 60 degree, so this is 30 degree, 90 degree minus theta. So it is observed that the projectile undergoes the same range. Okay, if I keep u fixed and if I change the angle from theta to 90 degree minus theta, the horizontal range is not going to change. Why? Because range, it is 2u square sine theta cos theta by g. Because range is u square sine 2 theta because range is r is u square sine 2 theta by g. This is the expression for sine 2 theta is 2u sine theta cos. So sine 2 theta can be written as 2 sine theta cos theta. So I can write the expression for range like this. I can write like this also. So this is the range when angle of projection is theta. So I am writing it as r theta. Okay. So range when angle of projection is 90 degree minus theta. So it will be 2u square. Theta will be replaced by 90 by theta. So 2u square sine 90 degree minus theta cos 90 degree minus theta divided by g. Divided by g. Sine 90 minus theta is how much? Cos theta. So this becomes cos theta, this becomes sine theta. So I can write this as cos theta sine theta. This is same as this expression, isn't it? So that means r theta is equal to r 90 degree minus theta. So that means horizontal range is same for complementary angle. Okay. Horizontal range is same for complementary angles. Okay, so that is theta and 90 degree minus theta. Horizontal range will be same. Heights will be different. Okay, height will not be same. Suppose this height is h1, this height is h2. Greater height is h1, smaller height is h2. These heights will not be same. Okay, but the range will be same. Okay, range will be same.